Today we're going to do the Honors Algebra 2, Chapter 4, study questions. State the degree, the type, the lead coefficient, and describe the end behavior. The degree is always the highest variable exponent. So in this case, the degree is 3. Now, it's a bit of a trick question because the lead coefficient is also 3. The degree is the highest exponent. The lead coefficient is the number in front of that. Describing the end or type now, it's a cubic. If it was an x squared, it'd be a quadratic. If it was an x to the fourth, it'd be a quartic, but it's a cubic. And then on your test, it will say as x goes to positive infinity, f of x goes to, and then it'll have a blank. And as x goes to negative infinity, f of x goes to blank. Again, that will be on your test already. So now it is a cubic with a lead coefficient that is positive, meaning the picture should look like this. Notice the going to the left would be downward, going to the right would be upward. So the first answer, as x goes to positive infinity, the f of x also goes to positive infinity. And as x goes to negative infinity, the f of x goes to negative infinity. Reason for this is the going to the left is going down, and going to the right it's going up. Do not put up or down. Put positive infinity and negative infinity. So the next one, degree is 4. Lead coefficient is -1. That makes it a quartic. Again, on the test, it will say as x goes to positive infinity, f of x goes to blank. As x goes to negative infinity, f of x goes to blank. So now, filling in the blanks there, it's a negative quartic. And so the both end behaviors have to be the same, and in this case, both of them will be going down, which means you should write negative infinity. Simplifying, that means you're adding or subtracting like terms. So I'd have a 3x cubed that has nothing that's alike. The 5x squared and the minus 3x squared would make positive 2x squared. Negative x and positive 4x make negative 4x. Positive 11 and positive 7 make positive 18. This is a popularly missed question on the test. Make sure when you square a binomial, you FOIL it. So first, outer, inner, last. So 4x squared plus 6x plus 6x plus 9, and add the like terms. Minus, don't forget when you're minusing everything in the second parenthesis. Some people would suggest that you rewrite the second one. So plus, and then change all the signs. You don't have to, but ultimately I'm again adding the like ones. X cubed minus 7x squared plus 9x plus 1. X times all 3, -2 times all 3. And again, add the like terms. Pascal's triangle. On the test, it will have Pascal's triangle written for you. So this would be given to you. Now, I'm trying to find a binomial to the 5th power, which means I will use the 5th row of Pascal's triangle. So I'd have a 1, a 5, a 5, whoops, let me try it again, a 10, a 10, a 5, and a 1, and I realized I kind of ran out of space, but there are the terms that you would need. Now, you're going to take the first term in the binomial, which is 2x, and I'm going to do each one of these in descending order. So 2x to the 5th, 2x to the 4th, 2x to the 3rd, 2x to the 2nd, 2x to the 1st, and technically it's 2x to the 0, even though that's going to be 1. Then I take the -5 and do it in ascending order. So I have negative 5 to the second, negative 5 to the third, negative 5 to the fourth, and negative 5 to the fifth. Now, with that being said, I am going to do each one of those individually. So 2 to the fifth, x to the fifth, times negative 5 to the 0 times 1 would be 32x to the fifth. Each one of these is done individually. So negative 400 x to the fourth plus 2,000 x to the third minus 5,000 x to the second plus 6,250 x minus 3,125. And that is the 2x minus 5 to the fifth power expanded. Again, each term is done individually. And so make sure that you look at that. When you do something to the fourth power, for instance, make sure both of those are taken to the fourth power. Long division. 4x plus 3 is being divided into 8x to the fourth minus 2x to the third minus 10x squared plus x plus 4. All right, so now I look at the first term of each. So I'm looking at 4x and I'm looking at 8x to the fourth. And so I would need to multiply by 2x to the third, which gets you 8x to the fourth plus 6x cubed. Always change the signs because you are subtracting, and then pull down the next term. I'm trying to go from the first term of 4x to negative 8x cubed, which would be negative 2x to the second, which gets you negative 8x cubed minus 6x squared. Always change the signs to subtract and pull down the next one. Again, I'm trying to get from 4x to negative 4x, so that'd be negative 4x squared minus 3x. Change the signs to subtract, running out of space here, so I'm going to move it up just a little bit. So this would be a plus 1. Pull down the next one. So 4x plus 3. Change the signs to subtract. I get a remainder of 1. So plus 1 over 4x plus 3. Another long division question. This time I'm taking 2x to the fourth plus 8x cubed plus x squared plus 13x plus 6, and I'm now dividing it by x squared plus 5x plus 3. So now I'm looking at the first term again and trying to decide what I would need to multiply by. So I'm going to need to multiply by 2x squared plus 10x squared plus, 10x cubed, 6x squared. Change the signs in order to subtract. Negative 2x cubed minus 5x squared plus 13x, pulling down the next term. Starts over again. So this would be negative 2x. So negative 2x cubed minus 10x squared plus, minus 6x. Notice that I am multiplying the negative 2x to all the terms. Change the signs in order to subtract. And so 5x squared plus 19x, and I'll pull down the next one. Last one here now, it's a plus 5. 5x squared plus 25x plus 15. Change the signs in order to subtract. I get a negative 6x minus 9. So now, how I would write that? Now, you can write it as a plus negative 6x minus 9 over x squared plus 5x plus 3, or you could have written it as a minus sign and then change those both to pluses. So a minus, and then it'd be a positive 6x and a positive 9. So one of those two ways, I will accept it either way. It's basically having a plus minus sign. Synthetic division. Always look, when you are dividing by just a binomial, you can use synthetic division. You would use the opposite value as your divisor. Pull down all the coefficients. Notice that there's none missing, so I don't need to put in any zeros. Pull down the first number. 2 times 3 is 6, and I add. 2 times 4 is 8, and I add. 2 times 12 is 24, and I add. And 2 times 13 is 26, and I add. because you're just dividing, this is not the remainder theorem, then I would just write my answer as 3x to the third, 4x squared, plus 12x, plus 13, plus 32 over x minus 2. Next one. Now, we have taught you two different ways to do this particular question. Using -4 for my function. Now, for some reason, my function didn't come out here, but I will write it out. It's 3x to the third plus 2x squared minus 4x plus 5. So now 3, 2, -4, and 5. Pull the first number down, -12, positive 40, and -144. So the answer to this question is -139. Now you also could have done it this way, and on the test we will not take off. You can do it in either way, but you can plug -4 in for all the x's and you would still get -139. Factoring now, okay? A lot of different factoring we have here. First one is factoring a perfect cube. So 2 cubed x cubed plus 5 cubed. Here's how this would factor. Take just the way it is without the cube. And then it's a pattern. The first term, okay, the first term, so 2x being squared. Then I change the signs and multiply the two terms together. And then I always add the second one squared. That's how to factor a perfect cube. All right, there's the next one. Always look for a GCF first. Then, because this is a trinomial and the degree of the second one is half the degree of the first one, you can actually factor this just like you would factor a normal trinomial. Factors of 4 that would get you -5 would be -4 and -1. And now I look to see if it can factor again. Now, both of these are perfect squares. So this would be x minus 2 and x plus 2, x plus 1 and x minus 1. And so remember, this is all about factoring completely. So not only are you going to have to take out the GCF, not only then are you going to have to factor the trinomial, then you're going to have to factor the difference of squares. Grouping. Take the greatest common factor of the first two, the greatest common factor of the second two, and I group. Remember, the theme of this is always factor completely. That first one can be factored again because it's the difference of squares. And so I have x minus 2, x plus 2, and x minus 3. Next one, is there a GCF? The answer is yes. I can take a 2x out of each one of those. And now, factoring the multiply the outside two numbers together is -18. I need factors of -18 that would get you -7 or -9 and 2. Setting the outside parentheses as one of them, I'm going to use -9. The first term and the last term. And then it's a matter of filling in the blank with what you are missing. And don't forget the GCF. Find the remaining factors. So I'm telling you that this is a factor. So I'm going to divide so that I can get down to something that is factorable. -11. Now the remainder should be, if I do this right, the remainder should be 0, and it is. So now, remember, it is asking me to find the remaining factors. It is not asking me to solve. It is merely asking me to find the remaining factors. You will get points taken off if you go further than that. It is not a solve question. It is a factor question. Find the remaining factors. Now I am actually trying to find zeros. Okay, find all the zeros to the following function. Now, I believe we missed one here, so I will put it at the end. So we're skipping to number 10. I want to find all the remaining zeros to the function. So I'm going to put this into my graphing calculator, and I'm going to find one zero that works. When I put it in the graphing calculator, 5 worked. So you have to prove it. You cannot just write down the answers that you think it is. You must show your work on this. 5. So I'm going to do, the remainder should be 0 if it actually works. And it is. So now I am down to a quadratic. You have options here. The quadratic formula. You can do, if there's a square root, you can do that. This ultimately factors. I always go to factoring if I can. So this factors. Set the parentheses equal to 0. And I'm sure if you were looking at your graphing calculator, you might have saw that -3 halves and -1 and 5 are all solutions. Again, you will not get credit if you do not show your work. Next one. Again, looking at the graphing calculator, I need to find one solution. I found -1/2 on my calculator. So when I typed it in, again, you must prove that it actually does work. And it does. Now, this is not factorable. So I have options here. Now, some people would say, go ahead and simplify it by dividing everything by 2. That's okay, you don't have to. But -b plus and minus the square root, b squared minus 4ac all over 2a. So I end up with 7 plus and minus the square root of 45 over 2, which reduces to be 7 plus or minus 3 square roots of 5 over 2. So on my calculator, I found 1, and then using algebra and dividing, getting it down to a quadratic, and using the quadratic formula, I found the other 2 solutions. Remember, fundamental rule of algebra says if it's an x to the 3rd power, then there must be 3 solutions. Last one in this group, it's an x to the 4th power, so you're really going to need to find 2 answers off the calculator. -3 was one of the solutions that I found when I type it into the calculator. So again, you need to practice typing this in the calculator. You need to practice on finding the solutions yourself. Again, you must show your work. You will not receive credit if you do not show your work. And so yes, it works because you get a remainder of 0. Now I need to find another one off the calculator. And I found 1. And again, it works. So now I am down to a quadratic. Again, you have options on how to solve a quadratic. This one is not factorable, so I'm going to go straight to the quadratic formula. -b plus and minus the square root, b squared minus 4ac all over 2a. So I get 6 plus or minus the square root of -4. 6 plus or minus 2i then over 2, which reduces to 3 plus or minus I. Again, there's supposed to be 4 solutions to this problem. -3 and 1 are both real solutions, and 3 plus and minus I would be 2 imaginary solutions. Write the polynomial function. All right, so now if x equals -2 and x equals 3 minus the square root of 7, then x must also equal 3 plus the square root of 7. Okay, all irrational answers must come as pairs, which means x plus 2 equals 0, x minus 3 and plus the square root of 7 equals 0. And so what I am doing is I'm taking the solutions, I'm making them equal 0 because those are the factors, and then I'm taking the factors and I am going to FOIL. Now, this is a giant FOIL question, and I highly recommend that you multiply the second 2 first. So if I'm going to take x times each, -3 times each, and square root of 7 times each. And I'm going to get x squared minus 6x plus 2. And then I'm going to take x times each, +2 times each. I'm going to add like terms, and I'm going to get x cubed minus 4x squared minus 10x plus 4. And so the function that has those answers would be f of x equals. Next one, same thing. If x equals 4 and x equals 2 plus 3i, then x must also equal 2 minus 3i. Notice that I'm only changing the sign in between. X minus 4 then equals 0. X minus 2 minus 3i equals 0. And x minus 2 plus 3i equals 0. So now I have created the factors that I would need to multiply together. Again, not going to show my entire work here, but I'm going to multiply these two together and add like terms. Some of them are eliminated, and don't forget I squared is equal to negative 1. And so you end up getting x squared minus 4x plus 13 when I multiply those two together. And then when I multiply these two together, I get x cubed minus 8x squared plus 29x minus 52. And so this is the function that has those three answers. Last one. Now, this is basically a calculator question. It is asking you, what are the x-intercepts? What are the locations where the local maximum and local minimum occur? So I need the point. And then I need the interval for increasing, and I need the interval for decreasing. All right, and you will have to graph this. So you basically type that in the graphing calculator, find the x-intercepts using the calculator function. There's only one x-intercept in this particular question. There's a local maximum. There's a local minimum. Now, I'm going to just do a little sketch here. It looks like this. Oops, I apologize, doing a little sketch here. It looks like this. So now there's the interval, this side would be decreasing, this would be increasing, and this again would be decreasing. So I start off at negative infinity till I get to 0.33. That's the x value of the minimum. Then it goes 0.33 to 3 is the increasing, and back to 3 to positive infinity as the decreasing. Odd, even, and neither. If you plug in negative x for all the x's, negative x to the second power goes back to positive. Look at the new function and look at the original function. If they are the same, it is considered an even function. So now if I plug in negative x and all the signs change, here's the new function, here's the original function, that is considered odd. And the last one then, if I plug in negative x for all the x's, this one would be positive, that would be negative, and that one would stay the same. If some of the signs changed and some didn't, you would write neither. Again, I'm going to go back and do number 9. I apologize, for some reason it was not on my PowerPoint, so I'm going to do this by hand. I believe the lead coefficient is 4, and the ending coefficient is 6. And so all the factors of 4 and all the factors of 6, remember you're always going to do the p's over the q's, okay? So again, p's over the q's, so 1 over 1, 1 over 2, and then 1 over 4. Again, I'm going to do this one over all of these. So then I'm going to do the next one. 2 over 1. 2 over 2 is a repeat, and 2 over 4 is also a repeat. So now 3 over 1, 3 over 2, and 3 over 4. Sorry about my plus or minus signs there. And then 6 over 1, 6 over 2, and 6 over 4 are repeat. And so therefore these are what's called the possible. I'm not actually asking you to find the solutions. I am merely asking you to find the possible. All right, that should conclude the Chapter 4 review. If you have any questions, make sure to talk to myself or Mr. Bone, and good luck on your test.